So, good morning, Honorable Present here. Course name 23 CST 207, Database Management System, second year, fourth semester. Unit number 5, Distributed Data System, Database. So, this is one of the other method to compare with ordinary database is a distributed database. So, we have using distributed database is different from others so that we can see the topic and we will discuss it. Thank you. So this is a distributed database. So logically interrelated to collection, share the data and a description of the data physically distributed over the computer networks. So distributed DBMS is software system to permit the management distributed database and make the distribution transparent to user. So suppose, for example, I am using any money to give to any other person means first I have transparent in front of other people's. For example, I'm saving. I will take a one glass box. I put a one coin in glass box and transparently, if anybody can see that one, how much coin to share, store in that particular box. So easily understand. So this same software system oriented is permit to management distribute database to make the distribution transparent one. So easily what's the data can go to uh, the place. That place means where will I will store. So whether I'm going to store in database server or cloud sectors. This is a way to represent and distribute DBMS in the area. So this is a command of architecture of a DBMS. So this is a for global data dictionary, and site 1 is site 2 computer networks database, and this is a DC, and LDBMS logically related the value based on DB, and global dictionary based on this one, because of each and every database can store logically interrelated is available or not. After that, in the area for logical or local database, DC data communication component, and global data dictionary in the area. Suppose I have received the one document, I logically locally database common I have verified. After that, and globally data dictionary. So based on condition of alphabetic order, I have stored in the area. One of the example hospital management server. So each and every patient, for example, inpatient or outpatient method. So first I have starting from 2025 and month and number of patient incoming per day. So after that I put a number manually or automatically. If suppose I'm using software, I automatically created. Suppose I'm using manually, I've lost number, I will check it and then I will give a ID number. This is one of the way to in the distributed share in the if any persons. So this is ideal situations. A single application should be able to operate transparently on data that area. So spread across a variety of different DBMS, running on variety of different machines, and supported by a variety of different operating systems, and connected together by a variety of different communication networks. So this distribution can be geographical or local in the area. So this is a database DBMS. One is site 1, site 2, site 3, and site 4, and connect with the database server. Whatever data I have received, first I store whether is a space is available. After that, I can store and backup data can be backed up through in database server based on my table. For example, create uh, table name open bracket and give a table detail. After create, automatically the query can be created one table. After that I have insert the value. After completion, I select star from the table name. After that, what I have create the table, what type of process I have inserted this value, and easily I can store in the area. This is a transparent one. So this is a distributed processing. This is a centralized database that can be accessed over a computer networks, site 1, site 2, site 3, and site 4. So advantages, organizational structure, shareability, local autonomy, and improved availability and improved reliability. So improved performance and economic one and modular growth. Disadvantages, complexity and cost, and security, integrity and control more difficult, and lack of standard, and lack of experience, and database design and more complex. So this is a distributed database environment. This is homogeneous, this is heterogeneous, autonomous, this is non-autonomous, federate, and multi-database. So this is homogeneous and heterogeneous. We have two type of distributed database. One is homogeneous distributed database. All the sites are identical DBMS and operating system in property are sites very useful and similar software. And sites identical DBMS or DBMS from the same vendor. Each site is aware of all other sites and cooperate with the other sites of process user requested, and database is accessed through the single interface if it is single database. So function of DBMS. So expect DBMS to have at least the functionality of a DBMS. So also to have following functionality. One is extended communication services, an extended data dictionary, and a distributed query process, and extended concurrency control, and extended recovery. Suppose I want to more value of concurrency control. Suppose safety and security means we have implemented one or more table in the included in concurrency control. So this is autonomous. We have using of two type of process. One is autonomous, non-autonomous. Autonomous, each database is an independent function its own. They are integrated by controlling application and message passing to share the data updated. And non-autonomous data is distributed across the homogeneous node and central or master DBMS coordinate and data to updated across the sites. So one of the example autonomous we have using Unicity. So non-autonomous using affiliated colleges. So this is one of the difference between autonomous means we have university means we have set the question paper, we have correct the paper and publish within a time period. But non-autonomous, first two things are same, but third one waiting for all zones are completed. After that, you can release the results. This is one of the way to non-autonomous. So this is a heterogeneous distributed database. A heterogeneous distributed database, different sites have a different operating system. So database, product, and data model in property. One is different sites use a dissimilar schema and software. The system may have a composed variety of DBMS like relational, network, hierarchy, object oriented. And sometimes relation is using of algebra. Algebra, we have implement query in algebra oriented, easily find out the answer. And sometimes we have using expensive one. Suppose if you want, you can access it. Otherwise, you no need your using of religion concepts. And query processing is complex due to dissimilar schema. Transaction process is complex due to dissimilar softwares. The sites may not have aware the other sites, and so there is a limited cooperation is processing user request. So type of heterogeneous distributed function, we have a federate and non-federate. So heterogeneous database systems are independently in nature integrate together. So the function is a single database. Unfederated database employ and central coordinating model through the which database are accessed. Suppose I have using two type of data structure, two type of structure data. For example, structure and unstructured means multicolor can be using in same process. Sometimes um, sometimes structured data means the same color same color can be stored one place. For example, you take a group of people, you can take same color means I can choose a red, the person can be rising of only red. Second, unstructured means if particularly I choose red, blue and black means you can choose this is unstructured data you can use in the heterogeneous distributed systems. This is a distributed DBMS architecture is based on distribution, autonomy, and heterogeneity. Distribution state the physical distribution of data across the different sites. Autonomy it indicate distribution of control of the database system, degree to which each constitutes DBMS can operate independently. Heterogeneity it refers to the uniformity or dissimilarity of data model and system component and database. So this is a architecture of DBMS. This is a global external schema. This is a fragmentation of schema, allocation of schema, local mapping, conceptual schema, and local internal schema, and DP. So first I have select star from the table name means first I have receive. After that check the fragmentation. After allocate object oriented. After completion mapping with schema. After conceptual schema is right. Suppose I am giving a semicolon all syntax are right, you can execute my process. If syntax is missing, sorry, query is not applicable. So once I receive conceptual schema is right, and then internal schema is going to internal schema. After that, we check my table whether this table is available. You can present it. This is one of the way to present in the architecture of DBMS. This is due to diversity, initially accepted of architecture such as ANSIC and SPARC 3 level architectures, and reference architectures consist of set the goal of external schema and global concept schema, fragmentation schema, and allocation of schema. Set the schema for each local DBMS conforming to 3 level ANSIC and SPARC. There's some level may be missing depending on level transparency and supports. So this is a compound of DBMS site 1, site 2, site 3. So GSC and DBMS data dictionary and global value and data DBMS DC and local logical or local DBMS and database server and GC. So database design, there are 3 keys. One is fragmentation, allocation, and replications. This is a fragmentation. Relational may be divided into the number of sub-relations which are distributed one way. So allocation, each fragmentation is stored on site with the optimal distributions value. Replication, copy of a fragmentation may be maintained by several sites. Thank you.